This video will cover the 9.3 integral test. This is one test to decide the divergence or convergence of a series. So for the integral test, the three main requirements are that it must be, your function, a of n, must be positive, decreasing for some value where x is greater than that value, increasing, continuous for all your values, and you must define a of n equals your function of x, or n. Once proving this, you can use the integral test, and that'll decide the behavior of the integral starting at your first value to infinity will match. So the series will diverge, and if that's so, then the integral will also diverge. Converge, same thing. So, for this one, number 21 from the textbook, we need to start out by defining this as a of n, and a of n equals f of x. Well, that means f of x equals x divided by x to the fourth plus 1. Then you must decide, okay, so no matter what, for all values x is greater than 1, this will be positive. Check. And next we need to decide whether it's decreasing. Well, to do so, it's easiest for us to take the derivative of this, f prime of x equals, and once doing so, we find out 1 minus 3 of x to the fourth divided by x to the fourth plus 1 squared, and from there we can tell that for all values x is greater than 1, it will be decreasing. And of course, continuous for all values greater than 1. So from there, we can take the integral. So the integral from 1 to infinity of x over x to the fourth plus 1 dx. Well, we look at this and we decide this kind of here. First that equals the limit is x goes to infinity, as b, value b goes to infinity of b 1 x to the fourth plus 1 dx. So we don't have an indefinite interval. Next, we can decide, looking at this, we can decide this looks an awful lot like our arctangent function, where u equals x squared, meaning du equals 2x dx. So figuring that out, we find the limit as b goes to infinity of b squared over 1 squared becomes du 1/2, because taking the derivative of u over u squared plus 1. And that, in turn, we can pull this out to the front. And that, in turn, becomes the limit as b goes to infinity of 1/2 arctangent, because that is our u squared plus a squared of u squared is defined at 1 to b becomes as limit as b goes to infinity 1/2 arctangent b squared minus 1/2 arctangent of 1. Well, in turn, as the arctangent goes to infinity, that equals 1/2. Well, multiplying that by 1/2, subtract that. Our tangent of 1 is 1/4, so we have 1/2 pi over 4. So that becomes pi over 4 minus pi over 8 equals pi over 8. Well, because we have a value here and not infinity or an undefined variable, we know that our integral therefore converges. And using our integral test, we know that if the integral converges, the series must also converge using the integral test.